So we started with wildcards last week, and I'm going to finish up by starting from introduction to regular expressions. So based on what we've learned so far, wildcards would help you search for file names. But then if you need to look for files, you need to look inside files, such as your FASTA files. You need to search for DNA sequences. Then you need to use regular expressions. So I'm going to share my Linux terminal now. Maybe I should just share my entire screen. Okay. So for instance here, so I have a FASTA file, this NSP60. First of all, let's check the content. So looking at this now, you can see you have so many sequences. And then let's say, for instance, you are looking for a stop codon somewhere, an open reading frame. You can't start looking for, oh, okay, so where is ATG here? And no, you even be lost. So you use, I'll be introducing, most of the examples we'll be using today will be grep. So first of all, okay, let's go through what is on slides first before diving straight onto the terminal. But let me just share my entire screen. I'm struggling with this thing. Okay. Can you all see it? Can you see my screen?
Yes.
Okay. So what regex allows you to do is it helps you search within files, unlike wildcards. And regex is a language for describing text patterns, because in bioinformatics you have a lot of patterns. So in your FASTA files you have headers, you have codons, you have gene names. So it allows regex allows searching patterns to be more flexible for you. So taking this example, for instance, so let's do grep. ATG, then this square bracket, ATGC, in, let's say, test.faster. I have a file called here. So if you look at this, I put the option here because if you use grep alone, grep alone actually follows the basic regular expression. But using this option E, which is the extended regular extension, recognizes special characters like this curly bracket. But if I done just grep, without that option E, it doesn't see anything. Even, okay, wait. Just bear with me. Okay, Can we see the difference? So I used grep alone without putting the option. So what happened, why it didn't work initially, is because grep alone doesn't understand special characters like your curly bracket, your plus, or your question mark. So for you to use grep alone, you have to put backlashes. I hope I'm not confusing anybody here. Before I now explain what the code is, I just wanted to explain to you why I added the option E to it. So if you use grep alone, you have to add backslashes. So you have backslashes here, and then you have here. Can you see? But because you don't want this to be very confusing and tedious and everything, so you just add the option E to your grep, and then it is cleaner, it is faster. So yeah, you are basically telling grep, oh, okay, so search for a sequence in test.faster that starts with, not starts, that has ATG, and then any of these nucleotides, A, T, G, or C. And you are saying, I want any of these nucleotides 3 to 6 times. That is what this curly bracket actually means. So this curly bracket together with that square bracket are working together. So you are saying any of these 3 to 6 times. So if you look at this, you will see ATG, which is here for every single one of them. And for instance, this first one, you can see it is A. In this square bracket, A is here. So it's either A, T, or G, or C. In this other second one, you can see it is G. Here it is T. Here it is A. And then from 3 to 6. So 1, 2, 3. This is 1, 2, 3, 4. 1, 2, 3. And this is 1, 2, 3, 4, 5. So between 3 to 6. Did you all get that? So I'm looking for this sequence. This is what I'm looking for. ATG, and then any of these nucleotides between 3 to 6, and then TAA. Does it make sense to you people? Can anybody hear me?
So someone has a question on the chat box. So they are saying that you should explain the beginning of what you just said again.
Okay.
That's Bridget.
Okay. You can still see my screen, right? Yes.
Yes.
So I'm using grep to find this. You can see my cursor as well, right? So I said the reason why I added this option is because without this option E, characters like this, example, this curly bracket, grep only understands the basic regular expression. So I okay, and then I did this example. Okay, no. This, no, not this one. Okay, this one. I didn't add the option E here. And then I'm saying, oh, okay, I'm searching for this. I'm searching for ATG. And then based on what you've been taught previously, in that square bracket, you're looking for either A or T or G or C, any of them. And then your curly bracket right after the square bracket is saying any of these nucleotides here, 3 to 6 times. So it can be, for instance, now, it could be ATG, AAA, and then TAA. It could be ATG, AAAA. I'm just using that as an example. So if you run this here, from the results we've gotten, we can see that, oh, okay, so we have sequences that have ATG, and then we said any of the nucleotides in this bracket, in this square bracket. So for instance, in this first one, you can see A, and you can see the A 3 times. That's the sequence that is found. You know, we said any of the nucleotides in this bracket between 3 to 6 times. That is what it's going to give you. So if you have, let's say, if you have ATG, and then you have a sequence that is just A and then TAA, it's not going to give you that because it does not fall between the range of 3 to 6 times. So either 3, 4, 5, or 6, and then followed by TAA. Is that better? Do you understand?
Sorry, please. I'm not sure I'm still clear. Do you mean positions 3 to 6, or you
No,
mean it
I mean the
appears three
number
to
of
six times?
times. The number of times.
But
Not
in these
position.
sequences that you're showing,
Yeah,
please can you show them again?
yeah.
Okay, AAA, the very first one, AAA appears 3 times.
Okay.
Okay. Okay, so it doesn't matter the position. GG. And then the second thing, does the G appearing 3 times include the initial ATG?
The G appearing 3 times. Which one are you referring to now?
The second line.
Okay, so now the second line you have ATG, which is what we specified here. You want ATG,
Yes.
and then it ends
Yes.
with TAA. So that means we're left with GCGC. So you said here
Okay.
that you want any of these nucleotides, either A, T, G, or C. So randomly, whatever you finds in your file, if it has G or A or T or C, and it appears 3 times, 4 times, or 5 times, or 6 times, it doesn't have to be maybe A. If it sees a sequence that is either A or T or G or C. Do you get?
Uh,
Still
well,
confused?
I really don't
Hello.
get it, but it's fine.
Tochiko, you are
Yeah,
saying
please, can
something?
you just try one number, just one number within the curly brackets, then before doing two.
Okay. So here now, I said ATG, and then any of these nucleotides, ATGC, 3 times. So if you look at here, look at the beginning, you have your ATG, and then we said it should end with TAA, and then this is TAA. You can see the things in between, I mean, the nucleotides in between appear 3 times. So here you can find a sequence that has AAA exactly 3. And then the next one, it has TGG exactly 3. So it's not saying, oh, you have to repeat the same thing, the same, oh, it has to be AAA or it has to be GGG. But the number of times the nucleotide appears, you've already indicated it in this curly bracket.
Okay, I think it's clearer now. Thank you.
So if you look at this one now, you can see that I said 2. But if you look at my screen, you can see that this part is not highlighted because this shows ATG. So it's either it begins from this side or it begins from this side. So it's highlighting from, oh, okay, so you have ATG, and then in between ATG, you can see CC, because I indicated just 2. Do you understand? So if I had 3, then comma 6. So I'm saying between 3 to 6 of this number of these nucleotides. Is it clearer?
Please.
Did you say it is, or you said please?
I said yes, please. It's clearer.
Oh,
Thank you.
okay. All right. So moving on. So did you guys get why I said I use the, so throughout a lot of the times I'll be using the option E, so to avoid using backslashes and all, since I want to use the extended regular expressions. So another example would be, so let's grep again. So we are looking for this. I think I have a file called lin.txt. Okay, so now what I've done here is I said I'm searching for this word, gene, in my text file. So gene, and then based on what you've learned from your wildcards, 0 to 9, I'm saying any digits that I find between 0 to 9, and then this plus here says one or more of these digits. So if he finds gene 1, I mean, if he finds a line that says, okay, for instance here, gene 1, it fulfills what you've asked it to do. If he finds one that says gene 1, 2, let's even check the content of our gene.txt first of all. So you can see that I have gene 1, gene 1, 2, gene ABC, gene 999, and then gene 5. And then I said, oh, search for gene, and then any digits between 0 to 9, and then I added the plus sign. So I'm saying search for gene, any digits between 0 to 9, and that digit can appear one or more times. So you can see that the output here is giving us is gene 1, gene 1, 2, gene 999. It did not give us ABC because ABC is not a digit. And if you look at gene 5, 5 is a digit, but gene is in capital letter, which is why it is not part of the output. Is that clear? Did we all get that?
Yes.
Okay. Okay. So we'll be doing a lot of examples. Okay, let me still go back to. Okay. So what we'll also be doing is we'll be testing some of the most commonly used regex characters. So you have your dot, your square bracket, which we've already started, the anchor, the dash. You can see there's an anchor here, there's an anchor here. I'll tell you how different they are, the dollar sign and this and so on. So let's just practice. So now let's do okay. Gene.txt. So based on what I previously said about when we were using the nucleotides, so now I've done grep and then okay, look for gene and then any digits and the caliber. What do you think the output? Anybody, what do you think the output is supposed to be here? If you understood what I've said previously, I need to know so that maybe we can go over again and then I can explain better if I'm able to. What do you think? Anybody can tell me, what do you think the output should be? Or what do you think this curly bracket is telling us with the one inside?
It's the one that is going to show.
Okay, so you're saying one is the one that is going to show.
No, the gene that has just 0 to 9 appearing once is what is going to show.
Okay, thank you. Anybody else?
I think, like she said, it means just one outcome, one output of
Okay.
any gene that has 0 to 9.
Okay.
Number 0 to 9.
Okay, so let's run this. So look at this now. We are seeing gene 1, gene 1, 2, and then gene 999. Does it fulfill the condition that we've put? Yes or no? We said, oh, okay, so search in my gene.txt and then look for gene and then digits 0 to 9 and then one time, just once. Is that what he gave us? Yes or yes? I'm asking the question so that we can be on the same page. Anyways, if you were to ask me, I will say yes. However, you can see that this is gene 1. You can see this line says gene 1, 2, and then this says gene 999. So what happened, or what has happened, is that, oh, he found gene 1. Yes, this fulfills the condition. You said you want one, a digit and then just one of it. And then gene 1, 2, oh, okay, this one actually has a digit as well, even though it is more than 1, but it still fulfills the condition. It has ignored these 2 and it ignored 99. So in situations like this, if you need to be very, very strict that it is exactly 1 that I want, you need to add this. Oh, sorry, TXT. Did you see the difference? Can you people hear me? Because it's like I'm talking to
Yes,
myself.
yes, we did.
But did you see the difference? Did you get the difference? This first one
Yes.
here, he said, oh, okay, I want 1. Apparently, the 3 of them, they fulfill the condition. They all have a digit as well. So he just ignored, oh, the extra things. Oh, okay, we'll still give it to her. She wants 1. So 1 is here, 9 is here. Okay, fine. But then I want exactly 1. I don't want the extra things. I want just 1 digit. I don't want 1, 2. I don't want 999. Then you add the $ at the end, which you can see the output here. So here you see, and also means at the end of the line that, oh, okay, just that 1 digit at the end of the line. So this is what this line is telling us here. Can you see my cursor? Okay, let me just move on then. You people can see my Tochukwu, can you see my cursor?
Yes, sure,
Yes,
we
we
can.
can.
Okay. So another thing we'll be doing as well. So we'll be testing out the dots. Please, if anything is confusing, please let me know. So let's use sequences. So here I said I want just a single character. That is what this dot here is signifying. Just 1 character, any single character. And if you look at it, we have A, and then the single character between A and G is T. Same thing here. And then the same thing here, same thing here, here, and here. You can see this is C. So you are not specifying whatever, you are saying whatever it is, just one, and then give it to me. So here you can see this is ATG, this is ATG, this is ATG. This is why this is showing like this. So from whichever angle you're looking at it from, this is ATG here, this is ATG here, so you just want a single, that is what that dot is signifying. You just want 1 single character. So we can change it to, so can we see the difference now? So this dot here saying just 1. So here you have AAA and then you have ATA. I think this one is straightforward enough for you to get. Can I move on?
Yes.
Okay. Please, if
But
anything
you
is,
can't see your thumbs ups. So maybe you can just say yes. I commit and say yes.
oh, okay, because I'm sharing my entire screen, so I'm just on my Linux, so I can't, maybe I should minimize then. I don't even know if this is. Anyways, okay. Maybe I'll be able to see now. So another example will be using so these are the basic regular expressions that you can see on the slide. So we are just testing them out to see how they all differ from one another and how they work differently. So we've seen the dollar sign, we've seen the dot, and now we want to see the square bracket, which we've seen before, but then we'll do it again. So in this case, we are telling it, okay, since we've mentioned it before, can somebody tell us what we are telling it to do here?
Ma, you didn't specify number of times, so I feel it's just going to look for sequences that start with A, ends with G, and has T or C in between.
All right. So thank you, Esther. So we've said, oh, okay, search for a sequence that has A, either T or C, and then G. So you can see here, we have C here, we have T here. So just like Esther has said, in this instance, I'm not specifying any number or anything. I'm looking for a sequence that is A, either T or C, whether it is, whether everything there is all T, or whether it's all C, or you can't find both. Like in this case, you have T here, and then you have C in this case. So that is what it is. So another example we'll be trying out. Okay, we've already done range, which is the number like 0 to 9. So I'll move on to anchors. So here you can see, oh, okay, I said search for this grep, search for this sequence as A, but not T. That is what this anchor is standing for here. I don't want T. And then it has afterwards and then G. So let's run. So let's check what is in our sequences first of all again. Sequences of txt. And look at what it has given us. Just one of them fulfill that condition without T. So he found, oh, okay, there's a sequence that has A and does not have T, that is not followed by T. You see that is, we found this one, like for instance, in this case, it is ACG. If it were to be, let's say maybe another one that were to be G, if the sequence were to be in these sequences was TXT, it will pull that one out too. But if you look at the other ones, you see, you have A, T. I'm not looking for that. And then I said after was G. So in this instance here, you have A, T, G. This is I don't want. You have A, T, G. This is another T. This is another T as well, which is why it did not give us any of this output. And the only one that I found to fulfill that condition is this one. So this anchor here means not T. So now, what will now be the difference between that and this one? Does anybody think there's a difference between what I've typed out now and the previous thing we had before? Like, I mean, the function of the anchor rather.
There's no difference since ATG is the sequence on its own, so it's not going to pick ATG. However, I don't know what is going to display as the result.
Oh, okay. Okay, can somebody, okay, thank you, Esther. Somebody else, what do you think the function of the anchor is here?
I think it's going to look for a line that starts with ATG.
Okay, thank you, Clement. Does anybody have any other thing or something different from what they've said? Okay, so let's try it out here. Okay, it seems I don't have. Okay, so let's do this. Okay. So just like Clement said, when I used it here, I said, okay, if you notice, when I ran this grep with my sequences.txt, it didn't bring out any output. Let's check out the content of our sequences.txt first of all. None of what is in this thing starts exactly with ATG. This starts with G, 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 Gin, 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 Gin. So here, what I've specified is that search for ATG at the start of the line, at the beginning. So it is different from what Esther said. I'm not negating this time around. And the difference is, if I were to be negating, it's going to be in the square bracket. And you can see that in this one, it is not in the square bracket. It is outside. There is no square bracket in this one, so I'm not negating. So I'm saying at the start of the line, I want ATG. Let me clear my screen so we can see. And if you look at the output of everything we have, all of them begin with ATG, which is different from what I'm saying here, where I'm saying, oh, I don't want T. Is it clear? Can we see the difference between these two anchors? Both of them are anchors, but then they perform two different functions in these examples.
Yes, ma'am.
Thank you. Any other person, do you get the difference? Okay. Thank you. So if you want it to end with ATG, then you put the $ at the end. So for instance, let's use my test is faster. I guess I don't have any sequence that end with ATG, but let's see. My test is faster. Neither do I have here. But let's see TAA in my test that faster. So because I can see a question that says, what if you want it to end with this? So the reason why the other one did not work when I did the ATG and then putting the $ is because I have no sequences that end with ATG in that document. So which is why I changed it to TAA. So if you want it to end exactly with ATG, but in this instance TAA, you put the $ at the end. So I said, oh, okay, search for TAA at the end. And if you look at all the outputs here, you can see that every single one of them end with TAA, not that it is in the middle or not. So at the end, and then you can see the one at the beginning in this instance. So does that answer the question of the person asking at the end? All right, thank you. So I'm still on this slide. So just like I said we'll be running through examples to that fulfill all the conditions of this symbol so that we can see how every one of them work. So another thing we'll do is grep. Let's see. So we've used asterisks a lot of times. What do we think we are saying here? Anybody? It has to be interactive, so I'll be asking a few questions as well. So we've used asterisks before. What do you think anyone think I'm saying here? So we said grep a and then asterisk, then in my sequences.txt. There's a reason why I'm asking you. If anybody knows the answer, can they please tell us?
I think it would show everything that starts with A.
Okay. Anybody with a different opinion? Thank you, Adela.
Yeah, I think it will contain A and anything, like anything after A. Or I think you can, yes, anything after A or anything before A, I think.
Okay. So in this instance now, we said grep A asterisk. Maybe I should not use this example. Let me use another example to break it down. Let's see. The difference, well, you are partially correct actually, but I would like to say that in this instance, the asterisk here, we are saying it should repeat T 0 or more times. It's different from when I say, it's different from, oh, look for 80 and any other thing after 80. No. What I'm saying here is look for T exactly 0 or more times. So it is either it finds no T, it is going to give you that output, or it finds multiple T's. So in this instance now, we can see 80. Then looking at this one, just look at what is being highlighted. Looking at this one, you can see, oh, okay, 80 as well, just a single T. In this one too, just a single T as well. I'm thinking I should change this example for you so it doesn't confuse you.
Sorry, sorry, please, I want to ask question.
Yes, please.
Is it contains T 0 or multiple times, or contains A and T multiple 0 or multiple times?
It is going to repeat, it is going to look for something that has either no T or T. So what is preceding the asterisk is T.
Okay,
Whatever is
because
preceding.
I'm
Okay, wait,
seeing
Adi,
A
right?
repeated.
Okay.
Yeah, because I'm seeing A also repeated 0 multiple times too.
Which is why I said you should
Yes,
okay, Adi, do you want to say something?
yes. Okay, I think these people are probably kind of like confused. So last week Shadula was it Saturday? Yeah, Shadula taught white card. So today Femi is talking about the regex. I mean the regular. So although if you actually look at both the white cards and the regex class, we can see that we have like two patterns. So there are some patterns that actually overlap, like all these asterisks, all these plus, all these asterisks, dots, and question mark. So you have it in regex and you also have it in white cards. So, but the distinction are kind of like they are different in a way. So in regex, so it's actually looking at the preceding character. So it's going to look at the preceding character. Like let's say probably you put T asterisk. So it's going to look at okay, T that are repeated is zero or more times. So let's say probably you put like probably a question mark. So it's going to look for a like any terms, any patterns that have a repeated like exactly one times. I mean zero and one time. Yeah, exactly one time I think. Yes.
Zero or more,
Zero
zero or
is zero
one.
is zero and one time. Yeah, it's zero
Yeah.
and one time. So let's say you now have like probably k plus. So it's going to look at k that are repeated like one or more time. So they're actually doing different things. I mean, in the white cards. So you use white cards to search for files, and you use regular expression to look within a file. So, and when you are searching within the file, I mean, there are so many ways that you can actually search within the file. It's either you use sed, you've not taught you sed, you can use grep, you can, but grep is actually what is being used here. So I think probably you should just probably look at it. There are some patterns that are, I mean, you will find asterisks in a wildcard session when you are searching for a file, probably when you are using ls to search for file. And you will see asterisk also in, I mean, regex, and they mean different things. So one is looking at the entire pattern. So the other one is looking for, I mean, it's looking at the preceding, I mean, the character that precedes. I mean, probably all of those asterisks plus uh, 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 and question marks. So I think probably, I'm not sure whether that helps in the but I think you should
So
actually have that in your mind so that you
yeah.
don't get confused. So in case you are still probably still thinking about what we taught you in white cards, I mean, it doesn't apply here for asterisks, for question marks, and for dots, and for plus. Yeah.
So in addition to what Abiba said, the using quotes, especially when you use um rejects, is also very important. For instance, now let me see, what do I have here? Abib, you are raising your hand. Okay, please continue while I'm searching for what I'm searching.
I'm not raising my hand, so let me just. So that was my old hand. So you can continue.
Okay. Where is it? I'm trying to. Sorry, please hold on. Okay. So in this, okay, let me do something else. In this example now, in terms of differentiating between the wildcards and then rejects, I said grep, gen, and then asterisk, then sequences dot txt. Just like how what you people were saying before about, oh, okay, it's going to look for this word in in this instance. I said gen, and then whatever is after. So for this, you can see I have gen 1 to abc, all these ones and everything like that. However, if let me add one more thing to my part. Okay. No. So in this instance now, and then compare it to this one. So looking at this now, I said grep, and then I put in quotes gen asterisk, and I said in sequences.txt. If you look at the output it has given us, we have gen. Oh, I'm supposed to even repeat n twice. Okay, but all in all, what I'm trying to say is, in this instance, what I'm telling it to look for is n multiple times. I'm not supposed to repeat e. The what I added is wrong. So nano sequences n. So in this instance here, so I said grep, and then I opened the quote, I said gen, and then I added the asterisk, and I said in sequences.txt. Basically here, I've said, oh, okay, look for gen, and then n either 0 or more times in this instance. So I'm in this instance, I'm using regex. It is regex. In the asterisk here is performing a different function from, oh, okay, look for gen and then whatever follows. No, what I'm saying is look for gen and then n can appear no time or more than one time. So if you look at here, I have gen, I don't have any extra n, it's still going to give it to you. I have gen here as well, I don't have any other extra n, it is going to give it to you. Same instances here, and here I have more than one gen. So it's going, you can see here you have gnn and then nnn. Just look at what is being highlighted. So the asterisk here is basically telling you 0 or more of the preceding letter, which is different from if I remove this quote, then it is bash that is going to run this for you. Not, you are not invoking the regex in this instance. So you are just saying, you are just searching for gen and whatever follows. I hope I have not confused anybody. I'm trying to just expatiate on what Abiba said. But did you get anything I've said here about the asterisks and now it's
Yes.
different?
Yes.
Okay. Thank you. So another example will be plus. So there are a lot of examples you can try actually. So we don't use, okay, but let's see. Grep. So yeah, this plus here is indicating one or more. So in this instance, you can see you have, oh, okay, you have GG, you have more than one. Here you have two, here you have one, and then here you have two, and then you have one. So in essence, you have regex like dots, you have your asterisk, you have your question mark, and you have plus. So for the question mark is at most, just like Abiba said, at most one or none. And then for the asterisk is 0 or more of the preceding letter or figure. Do you get? So let's just move on. Okay, we've done some of these examples actually. Okay, so if you look at this last line, can you people still see my screen? What do you?
Hello, Ma.
Hello, ma.
Sorry, I have a question. Good.
Okay.
Yes, I don't like quite understand this particular one you just took. The minus E, like this particular one you just took.
Is
Please,
it the
can you?
option E? Because I heard you
Yes,
say minus E now. Oh, okay.
yes.
Did you join late? Because at the beginning, I said the reason why I'm using this option is because using grep alone, it does not, it uses basic regular expression, and it does not understand these special characters like plus, like curly brackets, asterisks and all. So it's, before you can use that, you have to be adding backslashes. So to avoid that, just use option E. So you can use grep option E. Just like from your manual, when you man so this is the option I'm using here, the extended regex. So it says interpret patterns as extended regular expressions. So instead of having to put backslash, because the characters I'm using like plus and like question mark and the curly brackets in this instance, they are special characters. So grep alone does not recognize that, it will not run, it won't work, except I start adding backslashes. So, and I don't want to go through all that stress. So I just do the grep, add the option E, and then whatever it is I want to search for. Do you get now? It's like when you do ls and then you add option L, you want a longer format. Do
Oh,
you
okay,
get?
okay, I get now. Thank you.
Okay. Yes. So it's an option. It's an option. So now we want to look for exactly dot. And now I want to show us this example here. Do I have anything else exactly this? Hello. Okay, so I have this hello.word. And now I want to look for, let's say I want to look for a file that has, oh, this dot itself. You know, if I put grep, then search for dots in my sequences.txt. Yeah. Essentially, what is going, I've just told you that, oh, okay, grep and then any character. But that is not my aim. My aim, I'm searching exactly for a file that has the dot. So in this situation, what I will do is to add the backslash. So can we see now? It has searched for exactly dot. If I put, if you remember when we just started, I was like, oh, okay, some of the basic regex operators. So I mentioned dot, I was mentioning the curly bracket, the square bracket. And then when we use the dot, if you do grep a.g, it will look for a and then any character. So the dot there is signifying any character. But in this instance, that's not what I'm looking for. I'm looking for a word and in this case, in my own file, in my sequences.txt, I have a file called hello.word. And I'm looking for, let's say in another, maybe I have another file that is bio.info. And those are the two files I'm looking for. So if I had not added this backslash and I put the dot, it's just going to bring any character. But for it to be exactly the dot, you need to add your backslash. So you know that, oh, okay, it's a word that has dot that she's looking for. Do you get? Do you understand? So that is what this example here is showing us. And then in this instance as well, so if we're looking for exactly the dollar sign, because if you remember, if you just use the dollar sign, you're just saying, oh, at the end of a line, it has a meaning. But if you are looking for that particular, let's say you have a price of good, or you have, or I mean not price, or you have, oh, you wrote a code and then you've written, oh, okay, some $10, if $10 is this, blah blah blah, and then that is exactly what you are looking for. So let me see if I have any. Okay, like for instance, using this example now, I have here $30,000, and I know that this alone with a regex, I mean, I'm indicating at the end of a line, but that's not what I want to show. I want to look for the exact, I want to look for a word or a line that has this exact dollar. So what you do again is to add the backslash. Well, in this instance, I don't know why it is giving me this, but it should not be. Okay. So, because just like he gave us with the dot, it should here as well. Oh, Tochiko, Abi, do you know why it is not giving me this exact stuff here? Well, seems. Anyways, so but just like I've said, if you are looking for this exact dollar sign, you need to put the backslashes, just like it worked for the dot. Let's just move on so we don't waste time. So now we'll go to and then you can just go back to practice the the common ones here, just like we've practiced, and then just go to understand better. So we're going to finding files with locate, find, and which. So what locate does for you is, oh, okay, I want to quickly find something by their names. You can use locate. But one thing about locate is that locate uses a pre-built database, and which is often updated. It uses updates DB, something like that. So if you are searching for a file name and it has not been updated, it's possible that you don't find. So it is less precise than find, but find that is more precise is slower than locate. So for instance, now let's locate desktop faster. So that's giving me the path to where my test of faster is. So in this, using find, you have more control with find. You can tell it, oh, okay, in my O, or let's just do find so it is telling me that in my current working directory, I will find cgin.txt. So if I ls, cgin.txt is here. We know that here, this actually indicates the current directory that you are working at, this dot here. So, and then when you want to use which tells you what is executable, which executable will run when you type a command. So if I say which Python now, for instance, here I have on my laptop, I have Conda installed. So it is telling me that it is the Python from my Conda. That's what I'm using. So I think I'll just that's just a brief overview I'll give you with locate, because we are still going to pipe and we need to finish. So locate, you need to find files quickly. Find, it will give you more control. It is more precise, but it can be slower. And then, which will tell you what executable you are running. So now going to pipes. So what pipe does is it glues commands together. So it lets you glue steps, and the output of one command becomes the input of the other command. So for instance, now, if I do grep atg, and then this is the sign for pipe. That's the sign for pipe. And then I do WCL. Who knows what WC, like, you know what WC does, right? So let's take it one after the other. So this first line here, we said grep search for atg in sequences.txt. So now we've now piped it to word count, because WC is word count, and we are saying count the number of lines. That's what this option L is. So what it will do is it will search for ATG, and then when it finds them, it's going to count them and tell you the number of lines. So you can see that it's not listing out, oh, okay, these are the sequences with ATG. Okay, let me take this out then. So without piping, if you do grep ATG, find ATG in my sequences.txt, oh, it has found them. So you have this here, you have this here, you have this here, you have this here. But now I've told it that this output, this 4 output, count them for me, count the number of lines for me. And if you count manually, this one, we are using this example because we can count. This is line 1, line 2, line 3, and line 4. So what is it going to give you? You can see that the output is 4. Does it make sense? Do you people understand? So the output of this one, the output of grep ATG, is now the input of word count. So we've told it, okay, whatever you get from this one, count it. Do you people understand? If it's not clear, please let me know so I can go over it again. Wait, Tochukwu, are they giving me thumbs up? I can't see.
Yes.
Okay, thank you. So another example would be, okay, grep ATG sort, and then unique. So what we've asked it to do now, so let's take it one after the other. First of all, we know what this does. We know grep, okay, search for these sequences. I mean ATG. So what does sort do? Sort will arrange alphabetically for you. Before we let's just use a simple. So I have names.txt. So let's see what is inside names.txt. Okay. So I've got Alice Alice, I've got Bob, I've got Charlie, and I've got Alice. So let me do sort names.txt. Can we see that it has rearranged? Now you have Alice, Alice, Alice together. You have Bob, Bob, and you have Charlie. Unlike previously, when in my file, in my text file, I have Alice, Alice, and then Alice is at the bottom here, and then you've got Bob, Bob, and Charlie. But if I do sort, it has rearranged them. So you can see that they are all alphabetically. So let's see what unique does. So do unique names.txt. So what unique does is unique removes duplicates. And when you mean duplicate, you mean things that have repeated themselves. But if you look at this now, I said unique names.txt. It gave me Alice 1. And initially, we have Alice, Alice. That means it has removed the second Alice. It has removed this duplicate. And then look at Bob. It has removed one extra Bob again. And then we've got Charlie. But we have Alice again here. So the thing with unique is unique removes duplicate that consecutive. Is that the word? Yeah, that follow each other. Just like Alice and Alice, they follow each other here. But in this instance, this other Alice is not together with these two other Alice. So which is the reason why you need to sort first. And then when you sort, put all your words together. So you've got Alice, 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 and you've got Bob, Bob, and you've got Charlie. So now in this instance now, so if I do sort, let me clear. So let me first show you the content so you can follow like that. So this is how it is. So if I do sort names.txt and then pipe it to unique, that after you sort it, then remove duplicate. What can we see? Can we see any difference? Is it all clear? So what we've done is we've sorted it first. So it's not just, oh, okay, so that you can see your screen again. I told it to remove duplicates before. I said unique names.txt. And in real sense, it removed duplicates. But then there is still another duplicate in this case because Alice is repeating twice. So which is why you need to sort first. And then when sort, put your text, your whatever it is, arranges it alphabetically, then you can now remove duplicate, which is what happened here. So it has sorted it, which is our output. So the output from sorting is our input for unique. So can we see how piping is very useful? So now in this instance now, we now have Alice, Bob, and Charlie. So let's use another example. Okay, let's even say then going back to this one now. So we said search for ATG in sequences.txt. When you find them, sort and then remove duplicates. Let's see if we have files like that. So can you see we have ATG, 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 and then it has sorted them. If you look at it, they follow one another alphabetically. So this is gene 1. This is gene 1, looking at the first digits. 1, 1, 2, and 7. It has rearranged them. And then if there is any file that is the same as, let's say, gene 1, it has removed them. And if you need to count, you can add the option C. You can always use your man. Your man helps you to check, oh, okay, which option can I use? So here, I've counted the number of occurrences. So it's saying, oh, okay, this gene here, this gene 1 here is just one time. This gene 1 here as well is one time. This gene 1 here, one time. Okay, so Clement, I'm not sure I understand what you just said now.
Okay, somebody asked question. Okay, so question.
I saw you should be grep 77 or something like
Yeah,
that.
somebody's asking a question there. Yeah.
Oh, okay. So you were answering. Okay. Sorry about that.
You can help us answer the question. I don't know if it is correct.
What is messages? It's like I don't know how this thing functions anymore. Tochuku, what's the question? And maybe if you can answer, because I can't even see my inbox or in chat messages. Anyways, so maybe once I stop sharing as well. So do we see how piping actually works? So you take the output of one and then you make it the input of the other, just like we have done here. And then for word count, we have many options for word count. So you've got WC minus L. This is the number of lines. Okay, let's use this example here. So here he gave us 4. Number of words, 8. So he's counting the number. You know what words mean. So this is one word, this is another word, this is another word. So you've got different options for word count. So you've got words, lines, and you've got characters. So any option you want to use, whatever it is you are looking for. So I think, let me see, is that the last thing on the slide? Yes, I think that will be all for piping. And thank you for listening. I can stop sharing now.
Thank you.
I really hope I did not get to confuse you people, because we got to use so many of the common reject symbols, such as so, and then because we're trying to, really hope I didn't. So it's very good that you go back and then you check and make comparison. Oh, okay, we've got asterisks in this reject, and then I realized that, oh, the function here is different from when I was using it with wildcard. What makes it different as well? So when you get accustomed to it, you will know how to differentiate both. So you can go over and then you can always use your manual. And yes, so this is just the simpler part of it, just to at least make it easy for you. And then when you go through the textbook that is being sent, you can, okay, deal with, oh, if I want to test this and this and that, I know. So but hopefully I did not confuse, and I try to convince everybody. Okay, so any questions? Totuku, Abib, I think the mic is yours. So why
Okay,
I
thank you
added
very much.
C
So I think we have
for,
a question in the chat box.
yeah, why I added this C after the unique was because I wanted to count the number of occurrence. So that's what the option C is for, after the unique. So in the instance, I've already stopped sharing. If you remember the example I showed, when I opened my names.txt, cat, using cat, you saw Alice, then Bob, let's say Tochuku, and then Alice. So now I've sorted, meaning it has been arranged, and then I used unique to remove to remove duplicate. That means it's going to show me now. Since I've sorted, that means I'm just going to see Alice, Bob, Tochuku. So the C there is now going to tell me the number of times originally this Alice appeared. So I've had Alice 3 times, so it's going to do 3 Alice. I had Tochuku 1 time, it's going to be 1 Tochuku. I had Bob 2 times, it's going to be 2 Bob. So that's what the option C is doing there. I want to count the number of times the names appear, even after removing the duplicate. So you remove the duplicate, but how many times did they appear? Do you get now, Pamela?
Yes, I do. Thank you.
Tuchuku, I think the floor is yours.
Okay. So like I don't have anything extra to add. So do you have maybe further question from anyone? Or Kemi, do you have like maybe other ones that maybe we can go through since we have like some time to spare? Or you can even pick people to answer questions.
Okay,
If that
maybe we
works
should
for you.
do answering of questions. Okay, so let's see, what have we gone through today? So if I wanted, okay, in the instance where I typed in grep and then I was searching for, let's say, ATG, and then I said, and in my curly brackets, I put 1. I said, okay, just either of A, T, or G, and then 1 time. But then I can see that my output is giving me more than 1 digit after ATG. Or let me not use ATG, gene in this instance, just like the example I used before. So I use gene and I put, oh, okay, the range from 0 to 9, and I'm saying just 1 time. But then my output is giving me, oh, gene 1, gene 1, 2, gene 77, gene 772, and no. If I need it to be exactly just 1 digit after gene, what am I going to add, or what am I going to do? Do I give up?
To add the dollar sign.
So the dollar sign, where do I put it? The front, in the middle, or where?
At the
All
end.
right. Thank you. Okay, so I think I've mentioned this a couple of times as well. Is there a reason? What is the reason why I'm using the option E with grep?
That's because grep does not understand special characters like curly brackets. So using grep
Okay.
alone, sorry, it doesn't understand special characters like curly brackets. So yeah, if you don't use the effort, you have to use backward slash, back slash.
Yes, yes, yes. Thank you. Tochukwu, do you have questions for them? Okay, it seems it's not here. But any other question? But how was it easy to understand? First of all, I like to ask the question. Or was it easy, or maybe a little bit was hard or something to understand? Did you have any difficulty?
Hello, can you hear me?
Yeah, I can hear you.
So I said I'm trying to go over like the documents we have from the last cohorts. Let me see if I can find some questions. That might take a while. I'm still opening my system.
When does the class end? Is it 5:30?
It's supposed to be 6, unless you want to say end now. And then maybe the group leaders can take it from you, or maybe the textbook that are being sent.
Yeah. So I think a good number of them have left too as well, though. But I hope you people were not confused, though. So Bridget, you have a question.
Yeah, sorry, like you asked if there's any part that was difficult. I still do have issue with that very beginning. No, it's clear, it was not completely clear. The one that had 3 and 6 in curly brackets. I still do not really understand what we're searching for.
The curly brackets and the one where we had digits and a comma. Is that it?
The very first example you worked with, and there was 3 and 6, 3, 6. I think it was ATG.
Yeah. Oh, okay.
You
But
can
let me see if I can say this again. So basically that example, I'm saying we know that the square bracket is telling us either A, either T, either G or C, whatever it is. And then we already have a preceding code on that. We already put there the ATG. Okay, this is definitely a constant. So ATG is there. And then we put our square brackets. We said either A, either T or G or C, whichever one he finds. But then this either A, T or G or C, if they occur 3 to 6 times, if they occur between 3 to 6 times, so it could be 3 times you find nucleotides that is A or T or G or C. So it could be maybe AAA or ATG or ATGC or AGC, any of those nucleotides, but they need to appear between 3 to 6 times. That's what I'm looking for. It needs to appear between 3 to 6 times. Still confusing?
No, I get it now.
Oh, okay. Thank you. Any other question? And I also want to say, when you are using some commands, to also get used to using your man or your help. It will tell you which options you can use together with a command. Do you understand? Like when you put the option C, option L, option H, whatever the option is. So you can do man grep, man this. Do you understand? So you don't have to put everything in your head. Just you can always just check by checking your manual for the options.
Okay, so what I'll do, Tony, thank you very much. I'll just forward the document I have. So it contains exercises about wildcards and piping. So I think that could work for maybe for practice on what you've taught today. So I'll just forward that to the groups. Okay, so I think that should be all right. What are we doing tomorrow, please, Kim?